representation of vector quantities. Representation of vector quantities So, for representation we are having 2-3 method. One, let we can say graphical method. Graphical method. See, in this method we are using an arrow to represent the vector quantity. In this method, we are expressing a vector quantity with an arrow, a vector quantity with an arrow, the length of arrow, represent magnitude while and arrow direction represent the direction of vector, See, for example, let A is any vector quantity which is written as here 5 meter. So, A, it is also a symbol of vector quantity, 5 meter towards east. Let this, it is written as here. So, first of all, representation of vector. A vector quantity require magnitude and unit. 5 is the magnitude, m is the unit. Now, it also defined with a direction towards east. So, first of all, to define east, we should have little bit notation. Let this direction we can say east, this is your west, this is your north and this is your south, like this. So, if we have to represent a vector with a 5 meter towards east, I am taking here just for example, let 1 meter is, let we are assuming 1 meter is equivalent to 1 centimeter length of arrow. So, 5 meter means length of arrow should be your 5 centimeter and this should be directed towards east. So, we should represent like this. This is the arrow and this length should be a 5 centimeter. The 5 centimeter is equivalent to here 5 meter towards east. East, then this side, we can write here this is the vector A. Similarly, if another vector given, let velocity of particle is here 10 meter per second towards north. Let velocity of particle is let 10 meter per second towards north. Then see here, again we will first take a assumption here, let 10 meter per second. For example, let 2 meter per second is equivalent to 1 centimeter length of arrow. So 2 centimeter is equivalent to 1 centimeter length of arrow. Since velocity given here 10 meter per second, so 10 meter per second means we can say the length of arrow should be your 5 centimeter, and that is the velocity is along the north direction. The north is your upward. So we can make, let this is the arrow. Arrow represent here your direction, and the length of arrow here, again here this length is equivalent to 5 centimeter. So this indicates your velocity of this. So in this arrow, this is called your head, this is called your tail. So main point here, in the graphical method we are representing a vector within an arrow, and the length of arrow represent the numerical value, and direction of arrow represent the actual direction of the vector. Now in the arrow we are having two. So in arrow we are defining two terms. Let this is your arrow. So this part of the arrow called your head, and this part of the arrow called your tail. So whenever we are defining a vector with an arrow, there are 2 points here, head and tail. So now let another example. Suppose a particle is experience by a force 5 Newton along horizontal direction. So suppose it is given a particle is experienced by a force 5 Newton along horizontal direction. So whenever we are defining a vector, first we should define what is the horizontal direction. Horizontal, it can have your like that as well as like this, it depending on the question to question here. So if in the question this is given, let this your any surface, and in this surface this is a particle. So if a force acting horizontal in that side, then we will make, or we will show that with an arrow, and that force your F we can write here 5 Newton. And if force acting in that direction, this is also your horizontal, so then we can make a little bit your cross sign, and this indicate your direction of force your inward, and we can write here in the with a 5 Newton. So sometime we can define in the question to question in this manner also how a vector can be represented. This is the graphical method of representing a vector. Now see the analytical method of representation of a vector. Analytical method of representation. Method of representation. So in this method, first we will define our coordinate system. So as we know, we are having in Cartesian coordinate system 3 axes, x, y and z, and x axis we are representing with another symbol called your I cap, y is with another symbol called j cap, z is your k cap. I, j, k are also known as the unit vector. Unit vectors are the vectors which are having only direction and its magnitude is your 1. So these vectors can be multiplied with any of the quantity, so magnitude will remain same, but that give the direction. So first we are representing our coordinate system x, y, z. The coordinate system is just for a simple method of representing different direction. For example, suppose our east, west, north, south is also given. So, what can be said that east, west, north, south, that also we can represent with our coordinate system. In our coordinate system, if we are considering your origin, and from the origin right side is your x axis. So, east we can say let x axis, and this we can say with a I cap. Similarly, west opposite to east, then it is your minus x axis, then we can say here minus I cap. Similarly, north along the j, so then we can say here j, and south your downside minus j, and if they are talking about the upward like that, so this we can say here plus j, z or k cap, and inside minus j or minus k cap. So, this is the first representation of all directions. So, we have to represent first different direction on the basis of certain reference point. That reference point can be taken as a origin. On the basis of that reference point, we can define x, y and z, or in east, west, north, south, depending on the question to question. The first we will define our reference point, then we can define our east, west, north, south direction. The C. Now, if we want to represent a vector quantity, so let a particle start from rest, first it moves 5 meter towards east, then take left turn and travel 10 meter in that direction. Then again it took right turn and travel 15 meter in the new direction. Find the displacement of particle. From starting point. Let this is the question here. So, what can be done here? A particle starts from rest. So, the point from which it is starting, that point we can say let origin. So, let this is the point from which particle is starting, that is the origin. Now, according to the problem, say, it moves 5 meter towards east. East is this. So, 5 meter. So, we can say net displacement means initially your 5, but in which direction? In the east. How we can define? So, to get the idea it is east, then I am using here I cap. Then after that it is written here, then take left turn. So, if it is going in that side and taking left turn means towards the north. So, first we can say it goes in that side your 5 meter, then take left turn. So, how much travel? 10 meter here. After that they are saying in that direction, then again it took right turn and in that side. So this is how much here again, 15 meter. So that we can define total. So 5i in that direction, then 10 along that is called j. So 5i plus 10j, then again it travel 15 in this direction. So this 15 again we can say I cap. So finally we can say 15 plus 5 and a 20 meter in the east direction. So 20 I cap and 10 meter in the j means north direction. So 10j, this is the actual displacement of particle from the starting point. So in this manner we can represent vector in analytical form. So in the analytical form, first we would like to define our coordinate system x, y, z, or if our directions are given east, west, north, south, then we will define east as I cap, west that minus I cap, north j cap, and south is your minus j cap. So this is the way by which we can represent a vector quantity.